Alright guys, um, we're gonna start off making our intermediate projects now. Well, this project is gonna be a standalone video, but I'm working on a whole collection, or like a playlist of videos that this is going to go into as well. But anyways, this is the intermediate project, and what we're gonna do is build a AI Tic-Tac-Toe game. So if I make a folder here and say make another folder inside of that for our Tic-Tac-Toe game. And say tic-tac-toe.py. Okay, I'm going to try and explain everything I do as much as I can. Okay, so we're going to use two libraries in this project. So I'm going to import random and we're going to import OS. So what random does is it's a library that includes the random module obviously, and this library provides functions for generating random numbers. The way we're going to use it here is, for example, on who goes first, and then the OS library is a module that lets us interact with the operating system. We're going to use that in this project for clearing the terminal, just for a neater and slightly more aesthetic output of the game. Okay, now we're gonna do a little setup for the game. So we're gonna have two say main variables, and that is human, and we will make that equal to x. Okay, and say our AI is equal to a note. Okay, no. And then we'll also make a scores variable and say human -1 and AI is 1. I'm going to say tie is going to be 0, just like so. Okay, so what we've done here is that human and AI is just assigning the symbols that represent the human player and the AI player in our game, and the scores variable is creating a dictionary which will store the scores used by the minimax algorithm, and pretty much the AI wants to maximize its score, so 1, and the human wants to minimize its score, which is why we've written -1, and the tie is just 0. Nobody won, right? So nobody gets anything. I'm just gonna quickly explain like the minimax algorithm. So it's the minimax algorithm is like it's a backtracking algorithm. So we're using it for decision making and our game theory. So to ultimately like give us determine the best move for a player. This is gonna go for our AI, obviously, right? And the human is just going to use its own brain. So ultimately, the minimax algorithm is the brain of our AI in our game. Okay. So we're gonna make our board functions. So say def for creating our board, the function, sorry, and we're gonna say create underscore board for our function name, and so this will just create a new tic-tac-toe board, and it's going to be represented as a list of 9. elements. So what we'll do is just return none and times it by 9. Okay. I'm making another function to display the board, so def display underscore board, and we'll add a parameter. Parameters go into the brackets, and the parameter is board. So what we'll do is print say print string board 0, and we'll do or space like so, right? And then we can do plus that. Just sort of we're splitting out our board into columns pretty much. Okay, so and then we can do plus string board and go for 1 here, or like so, plus this like so, and this is going to be a blank space. Okay, and what we can do at the end is plus string board and then 1. Okay, or like so. I'm gonna do this. We can just print like print say 1 2 3 9. I mean, yeah, I think so. That's just for the lines going horizontally on our board. Now we can just copy this again and then do it once more. Okay, or make it do it one at a time. So now, this is going to be our third column. 3. This goes on to be 4 and 5. Oh, I've written 5 here as well. This is 4, and then we can just print it off again. This will just be 6 7 8. Okay. Now we want to do our we want to make a function for valid move. Okay, so we'll just do def valid underscore move, and then we'll do board as a parameter, and we'll do move as a parameter. Okay, so what this will do is check if a given move 0 to 8. So see how we start at 0 and we end at 8 on our board as a possible places that the user will be able to assign their value to. So what we can do is just do we can make a return move in range 9 and say and board move to be none, is none. Okay, so now pretty much create board just creates defines a function which is to initialize the new game board, and none times by 9 creates a list of 9 elements which are all initially set to none, representing empty squares. Our display board function is defining a function to print the current state of the game board. So the string board 0 or empty spaced string is the empty board. So it pretty much just handles displaying either the player's mark X or O, whatever you guys set it to, or a space if the square is unused or is empty, you know. Now finally, the valid move function. It defines the function to check if a player's chosen move is valid. So, for example, move in range 9 ensures a move is a number between 0 and 8. The board move is none. Checks if the corresponding square on the board is empty. So, for example, if the AI or even the user has already filled in, say, the first column, the first square, so top left, and they try and fill it in again, it's just going to not allow them to. And we'll continue with that with the code now. So we're going to go for the player input. So say def get underscored human underscored move, and we'll say board as a parameter. So while true, say try, we'll try to say take an input, so move is equal to integer input because we're taking an input of a whole number, and we'll say enter your move, and we'll just let them know 1 to 9. Okay, we just add a space at the end of any input just to make it a bit neater. Otherwise, the question and the input of the user is going to be clogged up like so. So we don't really like that. It just neatens everything up slightly. So now we're going to do so if valid. We're going to call the function valid move function and say valid move and say board move like so. Then return move. Otherwise, so else, we can do print invalid move. Try again. Okay. Numbers 1 to 9 only. And then, since we started a try block, we need an exception to finish it off. Except, say, value error. And we can say, okay, now we can just say print try again, numbers 1 to 9 only. Okay. Now what we're going to do is we'll make the AI functions. Or sorry, let me explain what this code does. So this function defines this defines a function to get the human player's input, and it also ensures that it's valid where we use the valid move function. And the try and accept is used for error handling. So our exception is only that value error. Our while loop just creates a loop that continuously runs until a valid move is entered. And what else? Our move variable, which is holding a input of an integer, is just asking for input, and it will convert it to an integer. So it's the board positions. And unless you write -1, so it indexes it properly. So now the user can write 1 to 9 instead of writing 0 to 8. Now we'll make other functions for our AI and do it a bit slowly. So as well. Okay, just reply to this guy real quick, and let's get writing. So we want to make a function, say get underscored AI underscored move, and we'll assign board as a parameter. Why does this guy want to play CSGO right now? Okay. And say let's make best underscore move variable and assign it the value 1000. Okay, and best move for now is equal to none. Okay, and what we can do is say for move in range 9, we want to make a conditional. So if let's say if board underscored, or no, if board move is none, then board move is equal to AI, and score is equal to we'll use a minimax algorithm, say minimax board 0 false, board 0 false. Okay, and we'll say that board move is equal to none, like so. And now we'll make another if statement. So if score is greater than best score, then we can do best underscore score is equal to score, and say best move is equal to move, and then we can just return the best move. Okay, and then we'll make or let me explain to you what get AI move function does. So it's pretty much just determining the best move for the AI, and what we've done is for the best move variable we've stored, actually no, we'll do minus 1000 to give it the worst a really low score, because it's going to be probably smarter than the human. So the for loop is just iterating over all possible moves, and the board move is equal to AI just temporarily places the mark on the column for the AI, and the score is pretty much just calling calling the minimax function, which we will make just right after this, which is going to evaluate the resulting board. Board move none is just removing the temporary mark that it made previously here. And well, the board move ultimately is just going to update the best score and best move if a better move is found from running that function. Okay, and what else? I think I've done this wrong anyways. Okay. No, no, all right. What we can do is make the minimax function now, I think. Yeah. Okay. So next one is here. So what we'll do is say def minimax, and we'll assign, oh my tea. Oh, it's so cold now. 1 second, just eating my donut. Okay, sorry about that. If I edit the video, then you won't see this, but I probably won't, so you will see this. But anyways, we're gonna assign some parameters for this. So we'll assign board, we'll assign depth, and we will say is underscored maximizing. Okay. What we'll do here is say, so what we're going to do is implement the core minimax algorithm, which is going to evaluate the board state. We'll say result is equal to check underscored winner board. Okay, and this is for another function we're going to make later. Okay, and say if result is not none, then return scores result. And we can say if is maximizing, then we can say best score is equal to minus 1000, and say that what should we do? Oh no, we can make a for loop. So for move in range 9, if board move is none, then board move is equal to AI, and score is equal to minimax board, oh my god, board depth +1, and make it false. So it's going to be the AI's turn. Okay. We can say board move is equal to none, and say best score is equal to max score and best score. Okay. And we'll just return the best score. Okay. So otherwise, so else, best score. So now this is for the human. Okay, so best score is equal to 1000, and for move in range 9, we'll say if the board move is none, then board move is equal to human, and we will say score is equal to something's telling me I've done something wrong. Yep, because this should not be scores, this should be score. And what else have I gone wrong? No, I haven't. Okay, so I was looking at this, why is this variable not coming up? So score is equal to minimax and say board depth +1, and we'll say true for human turn. Okay. So board move is equal to none, and we will say best score is equal to min score and best score. Okay, and we'll return the best score again. Return best score, just like so. Now we'll make some of the game logic. So we'll make a check winner function, and we will make the play game logic towards the end. Okay, so def check underscore winner, board as a parameter, and what we'll do is so we want to check the rows, we want to check the columns, and we want to check diagonals. Oh, and also we want to check for if it's a tie or not. So what we're going to do here is we'll say for row in range say 0, 7 and 3. Oh, I've done the wrong thing. 0, 7, 3. We want to say if board row is equal to board row say +1, and that is equal to board row +2, and board row is not none, then return board row. Yeah, board row, like so. And make another for loop, so for column, so for col in range 3, we want to do board if board row column is equal to board column +3 and is equal to board column +6. We want to, and it's also not none, so and board column is not none, then return say board column. Okay, now we'll make another for loop for checking diagonals. So say if board 0 is equal to board 4, and that is equal to board 8, and board 0 is not equal to, is not none, then return board 0. Okay, I'm going to do the same thing. We'll just copy this whole thing, save some time. Now what we're going to do is, so in this one, say if board 2, change this, is equal to board 4, 6, and we'll do 2 here, and board 2 is not none, then return board 2. Okay, and now we're going to check if it's a tie or not. So if no, this ain't. So F off, please. Okay. Okay, play CS:GO with this guy. So what we're going to do is make for our tie logic, we'll just do if all cell is not none for cell in board, then return tie. Okay, just do in total as a whole, we'll just do return none. Okay, so let me just explain this real quick. So what this is doing is defining a function for check winner, which is taking the current game board as an input. The goal is for the function to determine if there's winner, so human or AI, or if it's a tie. So if there is a winner, it will return the winning player symbol. If it's a tie, then it just returns tie. Otherwise, like if the game's not over, it just returns nothing, none, right? I guess that's the overall. Like, okay, you know what? I'll just explain the whole thing. So for rows in range 0, 7, 3, it just iterates over each row of the board, and you know, the rows start at indices 0, 3, and 6. So if the board row is equal to board row plus 1, so this line here, what it's doing is checking if all 3 cells in a row have the same or non-empty value, so X or O, human or AI. So if so, then that player has won. The return board row returns a symbol of the winning player. Now, for checking the columns, so this part here, what we're doing is iterating over each column of the board. So it's a similar logic to checking rows, but it's adjusting indices to check vertically. For checking diagonals, so this part here, so the first part just checks the top left to the bottom right diagonally, and the second part, so here it checks from the top right to the bottom left diagonally. Now finally, for checking checking if it's a tie, it just iterates over every single cell of the board, and if none of them are none, meaning all of them are filled, then the game is a tie, and it will just return tie. But if it's just return none, then that means that there is no winner just yet. Okay. Now what we want to do is make the logic for our actual game. So interacting with the game itself. So what we'll do is say start with making a function, so def play underscore game, and say, well, this is not going to have parameters in it, so we want to say we want to make a board, so board is equal to create board, like so. This will just throw in our board, and we want to display the board, so we'll do display board, and we'll just write the parameter in as board. Okay. Now we're going to use the random module, so if random dot randint 0 to 0 to 1, then it is equal to as 0, and we'll say the current player is equal to human. Okay, otherwise you just do else player or current player is equal to AI. Okay, now we want to make a infinite loop, so while true, if current player is equal to human, then we want to do move is equal to get human move, so move is equal to get underscore human move, otherwise else move is equal to get AI move, like so. Okay. Also, we'll quickly just make a. Okay, now I'll just define it and keep the flow going. So later we're going to make a clear terminal function, which will just add some nice aesthetics to the game, as it's just going to print out one singular board and keep updating there according to the moves of the computer and the human, and so just printing out multiple boards, board after board, right? So what we'll do is say that the board move is equal to current player, and we will say clear terminal, clear board terminal, and we will say display board. Okay, and so we're going to say winner is equal to check underscore winner according to the board, and say if winner is not none, then if winner is equal to tie, then print it's a tie, and otherwise else print winner. So winner, we could just make this into f string, to be honest. So winner wins. Okay, so it's just going to say AI wins or human wins. Let's just change this to 1. Okay. Oh, and else print winner 1. Okay. But if none of that works, then just break out of the conditional. Okay. So I'm gonna just say current player is equal to human if the last player was AI. So, otherwise, so else AI is the next player. Okay, and now, well, let me just go for a overview of the whole function. So we've just made a function called playGame, and it doesn't take any inputs, as everything it needs is managed within its scope. So all the previous functions we made. So the game setup is board. So we're creating a board from the previous function, and it's going to initialize a new empty tic-tac-toe board. The display board just displays it, and now we're checking with on what line is this? So we're checking on line 101. So if random.random 0 to 1, what we're doing is saying it's going to generate either a number 0 or a 1, which is, you can say, like a little coin toss, and it's going to decide who goes first, either human or the AI. Now the main game loop is just creating an infinite loop that represents the turns of the game. So this loop continues until a winner is determined, or if the game ends in a tie. So overall, it's just checking if it's the human's turn, and we're going to call it, if it's a human's turn, then we'll call it the getHuman function, getHuman move function, which is going to get a valid move from the human player. Otherwise, it's going to be the AI's turn, and what we do is do the same for the AI. We just call the AI getAI move function, which is going to let the AI determine its move using the minimax algorithm that we defined as well. The minimax algorithm, to be exact. Yeah, it's an algorithm. The board move is if the current player just updates the board by placing the current player's symbol, X or 0, X or O, sorry, at the chosen position of the move. The clear terminal, it does nothing just yet, but once we make the function, it's going to use the OS module that we imported, and it will clear the terminal, and just to provide a clean view of the updated board. The display board again then displays the updated board after the move. Winner is going to check, winner is able to check winner on the board. So what it's doing is calling the check winner to check accordingly on the rows and the diagonals if so who won. So it's just gonna define who won at the end. But if winner is not none, then it's just saying if a winner is found or a tie is found. If winner is equal to a tie, then it's just going to print out it's a tie, and otherwise it's just going to say so X or O won, to just define who won, like computer or the AI. Sorry, the computer or the human. Current player human if current player is equal to AI. Otherwise AI just says it's just alternating the current player for the next turn. So in simpler terms, the current player is going to be a human if the last player was an AI. Otherwise, if it was a human, then it's just going to be the other way around. So if it was a human, then it would just be an AI. Now what we're going to do is just make a function for clearing the terminal. We just say def clear underscore terminal, and say so how it works, right, is on Windows the command to clear the terminal is CLS, and on like Macs and Linux distributions, the command is to just type clear. So what we're going to do is, if os.name is equal to NT, then NT as in Windows, then os.system CLS. Otherwise, so else if it's not Windows, so os.system clear. So now what we're doing is this function just checks. So if the operating system is Windows, then just type CLS into the console. Otherwise, if it's not Windows, then just type clear. Now what we can do is finally just run the play game function like so. Okay, now if I run this Python script, oh, def clear term, oh, don't forget the syntax, my friends. Now if I run this, it has printed the board, but it's not going to work. So list indices must be integers or slices, not functions. What's wrong? What was the... Okay. List. Huh? I get it, but it should work. Why it's not working? I'm gonna ask our good friend ChatGPT, and then I can explain it to you guys as well, and I can learn what I went wrong with. I mean, the error is quite late in the code, so it shouldn't be nothing too hard to fix. So board move. ChatGPT can't figure out. Here's my whole code, man. I get the below error. That's... Why is it being so... Okay, whatever. I've also noticed that this and this the function, imagine, that's not going to be the problem. Okay, let's just debug this ourselves. So what this has said is get human move missing one required positional argument and board. So we'll just add board to the thing, and now it's going to say the exact same thing for the AI as well. Oh, it didn't. Oh right, yes, okay, no, it makes sense. So I want to add it to... Oh no, it will say it. It will say it. So if I type 1, it's just going to throw the error again. Object is not subscriptable. Alright, so now what we're going to do is finally run our script and see how it goes. So let's print out the board. Enter your move 1 to 9. Let's go with 5, so in the middle. See what the AI says. AI wants to go to first position. Let's go to the third one. Okay, we have to go to the fourth. Oh, let's go for 2. Yep. And we'll go for 9. or let's make an error on purpose to see how it's working. So I'm gonna go on position 1. As you can see, position 1 is already occupied. It's not free space. Invalid move. Please try again. Enter your move 1 to 9. 9. It's a tie. Ah. Okay. But yeah, that's the end of this video. If you enjoyed, like, subscribe, comment what else I can do. And yeah, this was like my first sort of tutorial, you can say. And well, I don't know how well I did, but let me know. Alright, bye bye.